Assalamu alaikum, dear students. Today we will move to the next topic, that is work, power and energy. But today we will discuss work. What is the meaning of work in physics and different kinds of work. First of all, in your daily life, work is used to describe any physical or mental activities. मतलब जो भी हम काम करते हैं उसको हम वर्क कहते हैं. For example, a student is considered to be do work while learning a lesson. A person who pushes a car but fails to push it is also supposed to perform work. But in physics, the term work has quite different meaning. When we discuss the work in physics, it is having quite different meaning. That means in physics, work is done. In physics, when we define a work, it has quite different meaning. Work is done on applying a force on the body and it has some displacement. That means work is done if and applying force. हम जब apply force करते हैं, applying force on the body and it has displacement, but in the line of force, it is important, but in the line of force, this is important. That means if a body moves, when we apply force on the body will move some displacement in the line of force. This is called, basically this is the meaning of work in physics. That means when we apply a force on the body should move a displacement in the line of force. That means in order to describe a work, it has two things, that means force and displacement. But in the direction of force. That means, suppose here, if a body is A at position A, if I apply a force A on position here, body is lying on here, it is at position A, applying a force, and after some time the body moves along at point B, and this is the position. A and B are the position of the body. That means upon applying a force, this is the displacement. This is the displacement covered by a body from this point to this point. This displacement from this point to this point. That means when we consider force F, applied on a body resting on the ground at position A, let the body moves to position B, so that displacement is S. Then work is done by the force is given by, it is work is equal to force multiplied by displacement. It is since we know that force is also a vector quantity, displacement also a vector quantity. Displacement in the line of force, please remember, in the line of force. We know that force is a vector quantity, displacement is also a vector quantity. If two vector quantities are multiplied in the same direction, it gives a dot product. If you remember in vectors, if two vector quantities are multiplied in the same direction, it gives a dot product. That means we can write work done is equal to F dot s. F dot s. Here that means f dot s. We know that, yeah, we can say dot product of two vectors is equal to fs cos theta. Fs cos work done is equal to fs cos theta, because the vector if two vectors are multiplied in the same direction, it use f dot s. We know that f dot s, dot product of two vectors, is equal to fs cos theta. That means when it gives fs cos theta, therefore it has no direction, therefore it is a scalar quantity. It is a scalar product, it has no direction, therefore it is a scalar quantity. But work does not have any direction, but it is having sign. Why it is having sign? Because there cos theta is having signs. Here we know that cos theta is having sign. It is cos, we know that cos 90 is equal to 0, cos 0 is equal to plus 1, cos 180 is equal to minus 1. Therefore work is having also sign. That means, but it has, if it has no direction, it is a scalar quantity, but it is having signs there. But work done is having sign. Why? Because of cos theta. Now suppose I take here another example here. If suppose roller, suppose I take another example here. Suppose here it is a roller here. Yeah. Suppose force, we are acting applied here in this direction, force is applied in this direction, but work is done in this direction. Suppose we applied, this is a ruler, we are applying a force F on the ruler. When we see the work done by this in the line of force, but in the line of force this body is moving in this direction, we are resolving this into rectangular component. यहाँ से हम इसको रिजॉल्व करते हैं और यहाँ से भी हम रिजॉल्व करते हैं. We know that it is that here suppose the distance covered is s, suppose as distance covered from this point to this point is s. We go, suppose the angle between this is theta. We know that this is fs cos theta. F cos theta is the component of force, and this is f sine theta. These are the component of the force. If we go work done, work is equal to force into distance. The force is equal to f cos theta into distance. Here suppose a constant force f acting on a body produce a displacement f in this direction. If theta is the angle which makes the positive direction, therefore component of force along x-axis is equal to f. We know that this is f cos theta. If it's f sin theta, we have already discussed. Therefore work done is equal to component of force. Which component of force is responsible for work done? Because body is moving in this direction, therefore f cos theta is responsible to move a body in this direction. This is called f cos theta into s. This is called fs cos theta. Yeah, work done is equal to, simply we can write work done is equal to f dot s. This is called positive work. That means here suppose it is here a ruler, for this work done is equal to fs cos theta. This work done, when we apply force in this direction, but body is moving in this direction, the amount of work calculated from this to this is equal to, it is called positive work. It is called positive work. That means for positive work, that means the angle, this theta, it should be less than 19 for positive work. That means मैंने already आपको बताया क्योंकि इसमें डायरेक्शन नहीं है, but it is a sign. Why it is a sign? Because cos theta is associated with the work. Therefore when cos theta is associated with the work, therefore for positive work, number one, for positive work cos theta, theta should be less than 90. That means 90, it should be acute angle. When theta is the angle, when we substitute in this, we get here the positive work. Then that means it is that between the work done is, that means the work done is positive. If you look towards the figure, if I apply force here, this is the direction of force, but body is moving in this direction. This is the amount of positive work less than 90 जो यहाँ से यहाँ work है. This is called positive work. Simply when we apply force on the roller, the amount of work done is positive work. One more work is that's called negative work. Negative work. इसका दूसरा जो है ना negative work आ जाएंगे. Negative work. Negative work. Negative work किसको कहते हैं? Negative work. We know that work done is equal to now Fs cos theta. Cos theta. Work done किसके बराबर होंगे? Work done is equal to, suppose this is the body is moving in this direction. Suppose a car is moving in this direction. When we apply brakes on the car, when we apply brakes are applying on the car, and brakes are applied on the car is moving in this direction. That means when we apply force, body moves along, the body moves this in the backward direction. That means in the direction of force, in the direction of this in the line, sorry, in the line of force, in the line of force. That means body यहाँ जा रही थी. When we apply brakes, the brakes applied on the car, ये यहाँ की तरफ आ रही है कार. When we apply force applying on the car, when brakes are applied, this force, the brakes applied for this is also called a frictional force. Frictional force, the direction of body must be in this direction. The angle between them is 180 degree. Such type of work, when we apply force brakes on the car, we get a work that is called negative work. That means for negative work, this, when we look here, it is for negative work, the angle should be greater than, it should be obtuse angle. That means it should be greater than 90 degree, and it should be greater than 90 degree. That means for obtuse negative work, theta should be greater than 90 degree. That means it should be obtuse. Here, when theta is equal to 180, when we apply brakes on the car, theta is equal to 180. When we substitute it, cos 180, we get is equal to -1. When we substitute in this equation, we get a negative work. Number third, that is called zero work. Zero work. मैंने already आपको बताया work किसके बराबर है? Fs cos theta. We know that is a scalar quantity. It has no direction, but it may be positive, negative, and zero because cos theta is associated with it. Value of cos can be positive, negative, or zero. What is the zero work? For that zero work, theta should be equal to 90 degree. When theta is equal to 90, F is equal to work done is equal to Fs cos 90. We know that cos 90 is equal to 0. The total work done is equal to 0. Example क्या है इसमें? Suppose we take the example, suppose this is the sun. The earth is moving around it. Suppose this is the movement of the earth. Velocity of the earth. This is the movement of the earth. But the force applied by the sun on this earth, this is called centripetal force. It is in this direction. But the earth is moving in this direction. That means they are not in the line of force. मैंने already आपको बताया work done वो होते work is done if applying a force, the body should move in the line of force, but they are not acting in the line of force. That means here sun is not doing any work, because अगर सन कोई काम करता है तो ज़मीन को अपनी तरफ खींचता है, यहाँ की तरफ खींचता है, मगर सन इज़ नॉट डूइंग एनी वर्क. तो बट द एंगल बिटवीन दीज टू, दिस जो डिस्टेंस और इसके दरमियान जो एंगल है, दिस एंगल इज़ 90 डिग्री. दिस इज़ द एंगल 90 डिग्री. दैट मीन्स दिस इज़ कॉल्ड zero work. That means when sun is not doing any work on earth, because sun is not doing any work, this is the centripetal force. Its direction is this direction is this. अर्थ यहाँ ये सर्कल के इर्द गिर्द घूमते हैं, है ना, सन के इर्द गिर्द घूमते हैं along the line, along this circular path. But this is the direction of the earth. This is the direction of the earth. This is the distance covered by the earth. But this is the distance. This is the centripetal force applied by the sun on the earth. But they act at 90 degree. That means when they act at 90, sun is not doing any work on the earth. Such type of work is called zero work. Zero work. This is the zero. This is the example of the zero work. When we apply brakes on the car, this is the example of the negative work. The motion of earth in a circular path around the sun, this type of work is called zero work. This type of work is called zero work. I hope you have studied, you have got all the three cases. Now we can come to the unit of work. Unit of work. We know that work is again Fs cos theta. Unit of work is joule. 1 is joule. How can we define 1 joule? Joule कैसे हम define करते हैं? unit of work is joule. How can we define 1 joule? joule 1 joule हो गया अगर इसका force 1 Newton, distance is covered 1 meter, and the angle between them, cos, it should be 0. 0. 0. That means they are moving along the direction. Cos 0 is equal to 1. 0 means they are acting in the same direction. You have got it. That means work is said to be 1 joule when work is, that means if I define work is said to be 1 joule when a force of 1 Newton actually moves a body through a distance 1 meter in the direction of applied force. In the direction of applied force, that means their cos 0 is equal to 1. Okay, I hope this is the, that means work is said to be 1 joule when a force of 1 Newton actually moves a body through a distance of 1 meter in the direction of the applied force. This is all about the work. Inshallah, we will move in the next class. We will discuss other terms. Thank you very much.